So today we're going to see how you can solve a system of equations using matrices. So let's take a look at this system. Let's say we're given the following system. Negative 7x minus 4y equals 15. 5x plus 6y equals negative 17. Okay? You should be able to solve it by elimination. You should be able to solve it by substitution. You should be able to solve it by graphing. We have 3 methods, but we're going to learn a 4th method today. And that's the method I want you to use on today's assignment. So what I want you to do first is rewrite this system of equations as a matrix equation. You do that by taking the coefficients of your variables and putting in the first matrix. This is called your coefficient matrix. Okay? The x coefficients go in your first column, so negative 7 and 5. The y coefficients go in your second column. And you're going to multiply that by another matrix. This is called your variable matrix. And that's going to be equal to this matrix here, which is called the constant matrix. And constant matrix is just these numbers right here. So this equation written right, this system of equations written as a matrix equation looks like this. Okay? Now this should resemble something that we've been working on. All of these are matrices. So you can think of this like as A. Let's call this matrix A. Think of this as X. So we got A times X equals, we'll call this one B. This is what you just solved. We want to solve for X. So we want to get rid of the A. So what we need to do is multiply both sides by the inverse of A. These cancel out. So X is equal to the inverse of A times B. So today, to solve a system of equations using matrices, we're going to use the multiplicative inverse. So what we got to do is we got to find the inverse of my coefficient matrix. Okay? So I'm just going to write down my coefficient matrix one more time so I remember it. So I need to see if this matrix here, my coefficient matrix, if it has an inverse. So does this have an inverse? Well, to determine if it has an inverse, you calculate the determinant. So we're going to find the determinant of A here. So we're going to multiply these together. Negative 7 times 6 is negative 42. And then when you're finding the determinants, always subtract. What are we subtracting? Whatever this multiplies to be. 5 times negative 4 is negative 20. So we got negative 42 minus negative 20 becomes negative 42 plus 20. So the determinant of A is negative 22. Now, we're going to use that to find the inverse of A. We're trying to find the inverse of A. So to find the inverse of A, you do 1 over the determinant. And we calculated the determinant to be negative 22. And then we're going to multiply that by this matrix. Remember, these two right here, we switch those. So So 6 will go here, negative 7 goes there. And then these two, remember we changed the sign of those. All right, so the inverse of A, that's what we're looking for. The inverse of A would be 1 over negative 22 times 6. So that's going to be negative 3/11. 1 over negative 22 times 4. That would be negative 2/11. 1 over negative 22 times negative 5 would be positive 5 over 22. And then 1 over negative 22 times negative 7 would be positive 7 over 22. Now, what do I do with the inverse? Well, I multiply that by my constant matrix that we called B. So my constant matrix, remember, was 15 and negative 17. I'm going to multiply these two matrices together to get what x is. Find out what x and y is. It's the inverse of A times B. Just draw our dividing lines in. And remember how we multiply. We're going to multiply rows of my first matrix times the column of my second matrix. So the first element in this row times the first element in that column. So we're going to take negative 3 over 11 times 15. That gives us negative 45 over 11. And then it's always add. The second element times the second element over here. So negative 2/11 times negative 17 would be positive 34/11. Now, let's do the bottom. So let's use this row now. 5 over 22 times 15 is 75 over 22 plus 7 over 22 times negative 17. It would be negative 119 over 22. Okay, so let's add these together. Negative 45/11 plus 34/11. Equals negative 11 over 11, which is just negative 1. 75 over 22 plus negative 19 over 22. That equals negative 44 over 22, which is negative 2. So remember what x represented. X represented my variable matrix. So our variable matrix was this. We had x and y. So what that means is x is negative 1 and y is negative 22. There's your solution. All right, let's take a look at this. So we started with a system of equations. Then we change it to a matrix equation. Then we found the inverse of A and multiplied by B to get my values of x, y. All right, I'm going to try one more example. You can do this with systems of 3 equations and systems of 4 equations and so forth. Alright, so I want to solve the following system. X plus y plus z equals 4. 4x plus 5y equals 3. And then y minus 3z equals negative 10. So if we do it like we did the first example, our first step will be to write it as a matrix equation. So this is my coefficient matrix. So we're going to list all the x coefficients first. So we got 1, 4, and 0. The third equation doesn't have an x variable, so the coefficient on the x is 0. Now let's list the y coefficients. We got 1, 5, and 1. List the z coefficients. We got 1, 0, negative 3. List out our variables, x, y, z. Our constant matrix is 4, 3, negative 10. So again, we're going to call this A, call this X, call this matrix B. To solve for X, we got to find the inverse of A. The inverse of A. And then what we would do is multiply both sides by the inverse of A, and then we'll get what X is. Well, we don't know how to find the inverse of a 3 by 3. It's complicated. We don't really have time. I don't really have time to teach you that. So if it's a system of 3 equations or more, I will give you the inverse of A. Okay? So let's solve this. Let me show you how we can solve this. The inverse of A is the following matrix here. Inverse of A is this matrix. Negative 15, 4, negative 5, 12, negative 3, 4, 4, negative 1, 1. So that's the inverse of A. So what do I multiply the inverse of A by? I multiply that by my matrix B. And remember, the matrix B was this matrix, 4, 3, negative 10. So we're going to start with our first row in our first matrix and multiply by the column of my second matrix. But before that, I always like to draw my dividing lines in here to help me. So this is going to be my answer. This is what x, y, and z is going to be. So we're going to start with our first element in the row times the first element in the column. So we're going to take negative 15 times 4 is negative 60 plus second element in the row times the second element in the column. 4 times 3 is 12 plus negative 5 times negative 10, 50. Let's add these together. So we got 2. So x is 2. Now, let's find out what y is. So to do y, I'm going to use this row instead of that same column. So 12 times 4, 48, plus negative 3 times 3, negative 9, plus 4 times negative 10, negative 40. Let's add these together and see what we get. So 48 minus 9 minus 40 is negative 1. So y is negative 1. And then last, find z. I'm going to use the third row here in that first column. So 4 times 4, 16. Negative 1 times 3, negative 3. And then 1 times negative 10 is negative 10. So we got 3 here. So the solution to that system is the point 2, negative 1, 3. So for systems of 3 equations or more, I will give you the inverse. But for systems of 2 equations, you're going to need to find the inverse yourself to solve it. So again, here are the 2 problems that we solved today using inverses of matrices.